Hello everyone and welcome to this new event. This time we will examine a vehicle with a fault in the engine control system. To solve it, we will use our IDC5 software and the integrated HaynesPro database. We will examine a Skoda Fabia with an engine fault that prevents it from starting. We will proceed with the diagnosis using TEXA Nemo 2 and the TEXA multi-hub vehicle interface. Let's connect to the vehicle and launch a scan of all the electronic units using the TGS3S function to see which errors have been detected. The results highlight some faults in the engine control system. In particular, there are the following types of faults: in the boost pressure sensor, in the fuel pressure sensor with the sensor reference voltage A. Let's select the guided diagnosis for the fuel pressure sensor and follow the procedures indicated in the page that summarizes all the information available. The guided diagnosis that is available shows us two contents: an electrical analysis sheet for the fuel pressure sensor, a smart case that is an already solved vehicle fault with the same error code, P0193, and the same type of defect. In fact, the title is "The Engine Does Not Start." Let's select the smart case and compare it with the fault detected in the Skoda Fabia. At a first glance, the problem seems similar, so let's follow the indications in the sheet and run the tests that are suggested. We will start by checking the parameter in self-diagnosis. For the fuel pressure sensor at startup, the value must range between 260 and 300 bar. Let's create a fuel pressure circuit logical group and try to start the engine. As you can see from the parameters, the value raises up to 300 bar. There is another value to check through the parameter page: the boost pressure sensor plausibility with ignition on. Here the value must be 1000 millibar plus or minus 10 millibar. Let's create a logical group of the parameters connected with this sensor. In this case, the value read is slightly above 3000 millibar. We are in a condition in which the fuel sensor's pressure is within the limits, whereas the boost pressure value is not within the plausibility range. Let's continue following the procedure suggested in the smart case and check using a multimeter if the power supply for these sensors is correct. In this case, we will use the electrical diagram that is in the list of guided diagnosis. Let's select the guided procedure for the fuel pressure sensor and run the tests that are suggested for this component, that are checking the voltage supply on pin 3, checking the ground connection on pin 1, checking the connectivity on pin 2. Let's start with the first test that checks the power on pin 3. First, we will use the position function to find where the sensor is located. We can see that the voltage value read by the multimeter is 0. The first test has failed. During the next test, we will be asked to check the voltage value directly from the pin in the engine control unit. Let's search for the position of pin B51 in the control unit and identify where the engine control unit is located. At this point, we have verified pin B51, and then there is no control unit power supply on it. In fact, when we looked at the errors in the engine control unit's memory, there was a fault with the description sensor reference voltage A. This means that the control unit detects that there is no outage on the output line and helps us understand that. There is no power supply for the fuel pressure sensor. The power line for the pressure sensor is in common with other components, as we can see in the wiring diagram. Our problem is that the 5-volt power for the sensors is missing. Let's see the two reasons why there is a lack of an electronically controlled 5-volt power supply: an outage, a short circuit to ground. There are not any fuses in this type of power supply. The engine control unit manages the protection against short circuits or open circuits. Let's start with the outage theory. To understand where the problem is, we have to check the continuity between pin 3 on the fuel pressure sensor and pin B51 on the control unit. Using the multimeter, we found that the line is conducting. Therefore, there is no outage. Let's pass on to the second theory and check for the possible short circuit between the power line and the ground. We have found the problem. The 5-volt positive line is short-circuited to ground. The next step is to understand if the short circuit is in the wiring or in one of the components connected to it. So, let's disconnect each component involved with this line one at a time and, using the multimeter, check if the short circuit disappears. Let's take a look at the wiring diagram and see which components we have to disconnect. The camshaft position sensor, the EGR valve position sensor, the fuel pressure sensor, the boost pressure sensor, the differential pressure sensor, the exhaust gas pressure sensor, the turbo pressure solenoid position sensor, After disconnecting all these components, we have identified the problem being in the turbo pressure solenoid position sensor that has an internal short circuit between the 5-volt positive and ground. And this caused the activation of the control unit outlet protection that shut off the power to the complete line. As we have seen, even in complex situations, the information and procedures available thanks to the HaynesPro database that is perfectly integrated in the IDC5 self-diagnosis are essential. The guided diagnosis included in the database and perfectly integrated in IDC5 allowed us to identify and solve the problem quickly and accurately. This is really a great advantage for us and our customers. Follow us on our channels to be always up to date on all the latest news from the world of TEXA.